Good evening. I would like to introduce Marken and Bushing, who are here to talk about Wii hacking. Last year, Bushing was here talking about Wii hacking, and 1 year later, this is the progress they've made. So if you'd like to give them a round of applause, please.
Thank you. As you may have heard, I am Bushing. I was actually here last year. I made a brief 5-minute presentation about the Wii. It was on no sleep after about 48 hours, and we had just managed to get unsigned code running for the very first time about an hour prior to the presentation. So since then, we've actually gone through and explored further, made some releases, and we're going to talk about that. So here is our presentation. All right. Talking about the Wii. Oops. So discussing the Wii, one of the interesting things about the Wii is that it is sold better than all of its competitors. I think most recently I checked and they had sold about 40 million of them, which is about as many as the Xbox 360 and the PS3 combined. Part of that is because it's pretty cheap. It's only about $250. Nintendo is very rare in that at that price point, they are actually making a profit on every unit sold, whereas I know Sony loses some amount of money every time you buy a PS3. They just hope you'll buy enough games that they'll actually make a profit in the end. The Wii is pretty portable. Hopefully we're going to have one up here in maybe 20 minutes or so to do a demo, but it's a small little box. Makes it easier when you have a pile of 3 or 4 of them. It doesn't take up the whole living room. One of the biggest things with the Wii is that it's backwards compatible with the GameCube, and this was very important because one of the biggest marketing weaknesses of the Wii has been its game selection. A lot of people have felt that it doesn't have very many good games, especially at launch. So something that helped was that it was already able to play every single GameCube game flawlessly right out of the box, and we'll talk a little bit about that later, why. They also tried to make it a very modern console and wanted to make it sort of a media-ish, newish console, and so they added built-in support for all the ways that you might want to connect things to it in your home. So we have Wi-Fi and Bluetooth, and you can use SD cards. It has a little photo viewer and an MP3 player, etc. One of the most unique features of this thing is something that Nintendo refers to as Wii Connect 24. And they're very vague on this point. They just sort of mention that it has something to do with online gameplay, and it's why your Wii light is orange instead of red when you turn it off, and yeah, some stuff. We'll talk about it a bit. As far as the actual hardware design goes, it is basically an overclocked GameCube in many ways. They use a similar processor, which is a custom processor from IBM, a version of the PowerPC that they codenamed Broadway. Runs at about twice the clock rate of the chip that was in the GameCube. It also uses a custom graphics processing chip called Hollywood from ATI. Again, it's similar to the one that was in GameCube, the Flipper, but about twice the speed. It has a pretty small amount of memory compared to the other consoles, but the memory it has is very fast. Also, they very aggressively manage the memory in each game, so it actually works out. The device came with the standard I/O ports that a GameCube had, meaning 4 controller ports and a couple of slots for proprietary memory cards. It only has 480p video output, which is, I think, worse than its competitors, but it's enough to power most consumer TVs. You know, it looks good enough for the market it's intended for. Also, it will work on standard definition TVs, which is a pretty big deal if you're trying to move units. As mentioned, it has a collection of ports. It has a built-in 0.5 gigabyte NAND flash, which is what it boots off of, and it lets you download and buy games from Nintendo and then save them onto the console, as opposed to just having to insert discs every time. It marks a big departure from, say, the GameCube, because it means that the unit doesn't actually just turn on when you put the disc in. You turn the unit on and it starts running stuff, and then maybe you put a disc in, or maybe you go play a virtual console game. Maybe you run your homebrew channel, etc. The drive that it uses is basically a DVD drive. It won't read DVDs, or at least it shouldn't. It's looking for a slightly modified DVD format that Nintendo created up with basically just to try to frustrate people trying to rip the discs. So if you take a normal Wii or GameCube disc and put it into your PC and you try to rip it, in general, it won't recognize it. And that's mainly just obfuscation. And they have this security subsystem, which is why it took about a year of hacking for people to actually be able to run any code on it. Let's see. As far as architecture goes, as I mentioned, they have two processors in this thing. They have the PowerPC, which is really what we thought of as the processor. This is what the games run on. It's pretty cheap and it's pretty off the shelf, but they run it at a very raw level. There's no hypervisor, no operating system or anything, so you're just running raw code on the thing. So there's no place for them to put any kind of security management on that. Also, the thing runs GameCube games, and there was no security then, so there's not really a whole lot they can do. And they came up with a very clever solution, which it took us a while to discover, which was that the graphics chip is actually also a I/O bridge, which is actually a full-fledged NEC ARM system on a chip. A nice chip decapping photo here, courtesy of our friends at FlyLogic. Unfortunately, this chip the features on the chip are so small and the chip is such a large area that it's, even with these high-tech tools, it's really pretty hard to get any information out of this. So all the information we're presenting here was gained just simply through disassembling software, and we weren't able to actually do some things like Karsten Knoll did with actually analyzing logic at an optical level. As mentioned, it's a system on a chip that we nicknamed Starlet because it's a little part of Hollywood. It runs a custom microkernel operating system written by Broadon. We'll talk about who Broadon is a little bit later. But it is all custom, which is interesting. So we were not able to leverage holes we might have found in UC Linux or any of the other standard embedded systems. Let's see. As mentioned,
Okay, the Starlet iOS basically verifies all code on the unit, or at least all code you would normally boot. So it verifies itself when you change to a different version. It verifies the games themselves. It verifies downloadable content and the system menu. So the entire boot chain is basically meant to be signed and authenticated. And well, it's really hard to run custom code because you can't directly boot anything through any normal mechanism. Oops. Okay. And yeah, and iOS is actually abstracted out. Developers don't even know what iOS is. If you ask Wii developer, they probably don't know, or they might know because they saw this stuff by us now, but they usually don't know. It's all abstracted out through API, so you just run a call and it gives you support for network or USB, and they don't actually say, oh, here's another CPU. They call it an I/O bridge, which doesn't really mean anything, and they just leave it at that. So it's really secret, to put it that way.
It really did work. They kept the existence of this entire processor a secret for a year and a half, which made it much harder to hack.
Okay, so the boot process starts, most of the code is booted from a NAND flash, but the boot process actually starts from a small ROM inside the unit. It's inside Hollywood, and it's really hard to get to. We've only been able to dump it pretty much by chance because we got there, but it's a small 1.5K bootloader that just verifies second stage bootloader from NAND, and it's very interesting because the second stage bootloader is actually hashed in SHA-1, and then that hash is stored in a one-time programmable memory area. So they make the Wii, they burn boot 1, and then they burn a hash into a little part of Hollywood which says you can never ever use a different boot 1 on this Wii. So they can change boot 1 at the factory, but once the Wii comes out of the factory, it's forever fixed, and they can never change it, updates or anything else. So boot 1 is actually a little more code, and it has RSA in it. So boot 2 is the main loader. It's kind of an iOS, but stripped down, no drivers. And boot 1 loads it and verifies it using real public key crypto techniques. Then boot 2, which is still a special piece of code in the NAND, then boots iOS. Oops. What the? Okay, that's what happens when you have too many buttons.
The joys of using our wonderful JavaScript-based slide package. So as Markin was saying, we have a three-stage boot process. This boot 0 that runs inside the ROM chip. This boot 1, which they can change, but only while it's in the factory. And then this boot 2, which is a fairly full-fledged bootloader that knows how to read files and run them.
Yeah, I'm just like way too nervous to hit buttons right. Okay, so IOS runs from NAND. It's actually in a file system. So boot 1 and boot 2 are special little reserved areas. IOS is resident in a little file system. So it's actually, there are several of them actually. And IOS is the main software for the startup. So when you're running games, when you're in the menu, it's IOS that's sitting there. And till now, the PowerPC is dead. There's absolutely no code powering the PowerPC. It's not even powered up. It's the startup controls the PowerPC. So it's kind of like a hypervisor in that it has control over what the PowerPC can do, and it can kind of peek at what it's doing. But PowerPC mostly has free reign. But IOS boots it up. So then the first thing that you see on a real Wii is the system menu, which is the little channel screen that pops up. That's PowerPC code that runs while IOS is running on the ARM. Boot 2 IOS menu, all signed using RSA, so it's all signed code. Since we can't change boot 1 either, the whole entire chain from boot 0 is signed. The reason for the whole boot 1 interlude thing that has the hash is so that they can update the security code, which is starts at boot 1, all the signature stuff, without making a new batch of chips. Like Microsoft with the Xbox, back in the Xbox days, had some bugs in their ROM. And the way they had to fix them was to actually trash a whole bunch of chips that had them. That's really expensive. So what Nintendo did is, let's put a really simple thing we can verify in ROM, and then put something more complicated in Flash, but make sure they can't change it ever, which makes boot 0 simple. So by doing that, they've actually been able to change boot 1 without touching it all, boot 0. So on the Wii, all software, which means channels, which is the little stuff on the Wii menu, games, disks, WiiWare, which is also channels that you can download, system software, they're all called titles. It's a unified signature and a packaging system. So they're identified by a title ID, which is just a little number. And titles are basically composed of basically three big important parts. They have the TMD, which is the title metadata, and that signs and describes the contents. So it's got things like the group ID, and that defines its permissions, and it's got the hashes of all the contents. So if you can verify the TMD, then it gives you an ability to verify the actual contents of the title. And the e-ticket is the license to the title. It's your decryption key for the title, basically. You've got common e-tickets, and you've got private e-tickets. So what they do is they can give you free tickets for system software, and then actually make you pay for tickets for downloadable content. It's got the AES key that decrypts the actual contents of the title, which is the data files and executable. And the master key for that, which is just self-encrypted, is stored in the one-time programmable area that we talked about. It's really hard to get to that because it's buried into Hollywood. The tickets can also contain time limits. So you could have like a demo. You don't think they haven't used this yet, but they can use it. Signatures are RSA 2048, so it's really like impossible to hack because it's modern crypto algorithms that are not broken yet.
And one thing I would interject is that this is another cost-saving measure. They're actually able to distribute all of the software using Akamai or other content distribution networks, because anybody in the world can go download the entire library of Nintendo's Virtual Console games, but they're all encrypted. So the only way you can actually play them is if you buy a ticket which has your key from Nintendo.
As I said, the games are also titles, but they're on DVDs, which have their own protections for anti-piracy. It's a DVD, kind of, not really. It has some tweaks they made to make it incompatible with DVDs. So it's got physical protections on it that are really out of the scope of this talk, but they're using special manufacturing equipment to do them. The disks themselves have data. Ignoring the tweaks, it's basically an ISO. It has several partitions. It's a special format. Those partitions are encrypted using AES, and they've got the